Okay, so today we have an implicit differentiation problem from the 2023 semester 1 test 3, and it says use implicit differentiation to find the slope of the tangent line to the curve, and we have our curve or our equation, and it says at the coordinates x, y, 1, 1. So the first thing we're going to notice is that we have a product rule between x and y squared. So as always, leaving the first function, and let's think about the derivative of y squared. So d by dx of y squared is going to be 2y, and it's with respect to x, so I'm going to multiply by dy by dx. So let's multiply by that, dy by dx. And we have a product rule, so I'm going to add. We left our first function alone, so in the next one I'm going to derive the first function. So the derivative of x with respect to x is just 1. And multiplying by, I'm just going to leave the second function alone because we already derived that. And that's going to be the first part done. So next term is x squared, and the derivative of x squared with respect to x is just 2x. Let me just erase this part. Okay, and that's going to be equal to, okay, the square root of x plus 3y. We can write this as x plus 3y to the half power, because I have a square root and this is to the power 1. So I can say power over root, and I can write it as a better form so that I can differentiate it. So let's differentiate this using chain rule. I'm going to move that to the front, so that's going to become half, and I'm going to keep whatever's in the brackets just how it is, minus 1 from the exponent, so that's going to become minus half. And by chain rule, I'm going to multiply by what's inside the bracket. So taking the derivative of x plus 3y, the derivative of x is just going to be 1, and the derivative of 3y is going to be 3 multiplied by dy by dx. Okay, so let me just make this a bit more simple. So this is going to be 2xy dy. I'm going to have the multiplication by dx, and this is going to be just y squared plus 2x. And on the right hand side, I can multiply this to the fraction. So if I do that, I can write this as a numerator, so I can have 1 plus 3 dy by dx. And using exponent laws, I have a negative exponent, so I can take that down to the bottom with the 2. So I'm going to have x plus 3y, and because of power over root, I can write that back like that. So that looks much better than what we had before. So the next thing we're going to want to do is say, well, okay, no, let me not have that. We can say, well, at the coordinates x, y equals 1, 1, we can just sub in 1 for x and y. So doing that, plus 1 squared plus 2 into 1, that's going to be equal to 1 plus 3 times dy by dx all over 2 into 1 plus 3 into 1, and taking the square root of that. Let's go down a bit, and we can say that's just 2 dy by dx, and 1 squared is just 1, and 2 times 1 is just 2, so adding those we can say that's going to be 3, and that's going to be equal to, numerator is going to stay the same, dy by dx all over, and here we have 1 plus 3, that's going to be the square root of 4, which is just 2. So that's going to be 2 into 2, which we can just write as 4. Okay, so the next thing I'm going to do is multiply both sides by 4. So doing that, I'm going to have, this is going to be 8 dy by dx, and that's going to become 12. And that's going to be equal to 1 plus 3 dy, actually I don't need to write the bracket, I can just leave it out, dy by dx. Okay, so solving for dy by dx, I can say, well, 8 dy by dx, and I'm going to move this 3 to the left hand side, and that's going to become a minus 3 dy by dx, and I'm going to move this 12 to the right hand side, so that's going to be 1 minus 12. So this is going to become 5 dy by dx equals to minus 11. And dividing both sides by 5, we get dy by dx is equal to minus 11 all over 5. So what is the slope of the tangent line to this curve at the coordinates x, y, 1, 1? Well, it's minus 11 over 5.